Hello students, in this lab we're going to be covering Kirchhoff's rules. This is probably going to be the most difficult lab that you're going to see this semester. So what I'm going to go over in this video is how to do the calculations for your first circuit, and then give you some intuition on how to set up the equations for a few more of your circuits that you're going to see in this lab. But I'm going to work pretty much through the first circuit for you guys. You're still going to have to do a little bit of math, but not too much. And you should have the correct answer with this. So what you're going to see here is a circuit that looks very, very similar to what you saw in your first lab, simple circuits. So you may notice that this is a parallel series circuit. This R3 is in series with R2 and R1, and of course R1 and R2 are in parallel. So this is, you can look at your last lab, this is basically that different version that I was talking about, that you can see a parallel series circuit in form. So the first thing that you guys need to think about when you're doing these circuits is how does your current relate to your circuit. So I like to think about it like water, right? So you have water coming through, and it gets to this little junction or intersection. Water's going to go to the right, and it's going to go straight. Now when that water splits up, the pressure of that water is going to decrease, right? But when it recombines here, it's going to come back to the same original pressure. So this is known as a junction rule, and we could write that. Now I named the currents after the resistors that they're on. So this current right here is R3, this current right here is I2, and this current right here is I1. So what we're saying is I3, when I3 comes here, it splits up into I2, I1. When it comes back together, it becomes I3 again. So we could say that I3 equals I1 plus I2. That's our first equation. Now we have to make another equation. Okay, the next equation is kind of going to be like the equation that represents the whole circuit. Now there's multiple equations you can make for this part, but and I'll give you an example. So the first equation right here, which is the equation I chose to use, is saying that our voltage delta V is equal to I2 R2 plus I3 R3. So we're saying this plus that is equal to your total voltage. Now think about this. In the simple circuits lab, I'll give you guys a little example on the back here. Think about when we had the simple circuits, right? Well, when you have a parallel circuit, all the voltage in the parallel portion is the same. So essentially all we're saying is that this voltage plus that voltage is equal to the total voltage. So this is where we could come up with multiple equations. And this is the problem, or the main issue students have with these calculations. It's extremely difficult, or students will ask, which equation do I use? We have more equations than we know what to do with. So the answer is you could use multiple equations to solve this problem. So two people could work this circuit out and have two complete different answers, and still they could have two different methods of working it out but still arrive to the same answer. So don't panic if you're comparing your notes with your classmates and they do it a different route algebraically. Now I put a little dash here. This is the equation I chose to use. Okay. Now the next thing is you're going to do a third analysis where you're going to realize, how do my loops, or my parallel portion, how do they relate to each other? So you're going to ask yourself, how does this portion relate to this portion? Well, you should know the relationship will be here. I1 plus R1 is equal to I2 plus R2. Now again, what we're trying to do is solve for all the currents, right? So we have three unknowns. We don't know I3, we don't know I1, we don't know I2. So in algebra, when we have three unknowns, we need three equations to solve that, which is what we have. You may notice we have 1, 2, 3. We have three equations, three unknowns. We have a fourth equation, but don't. But that's because there's two different ways you can work it out, and I'll demonstrate that in the next step. So the first thing that you could do is you could sub this equation into here, into I3. So this becomes this equation down here. Delta V is equal to I2 R2 plus I1 plus I2 R3. When you do that, then you decide which route you want to go. Alright, so I think it's easier to get everything in terms of I2. So I took my third equation here, and I solved for I1, so I could plug I1 in down here. And then once you plug your I1 in, you get everything in terms of I2, right? So you may notice you got delta V is equal to I2 R2 plus I1 plus, one more down. When you plug your I1 in, you get this right here. You may notice that's where the R2, R1 comes from. So now you have everything in terms of I2. So the next thing is to factor out that I2. And when you factor out that I2, you get this equation right here. You can take all this junk right here, divide it by V, and then you get your answer for I2. So to check yourself, I'm going to give you the solution to this portion. It's going to be 100 divided by 46 ohms is going to equal your current for I2. So that's just to give you guys a solution for that. Now once you get your I2, you can go back to this equation right here, plug your I2 in, you know your resistors, R2 and R1. Then you get I1. Once you get I1, you go back to this third equation right here, plug I1 in, you already knew I2, plug I2 in, then you get I3. So now you basically solved the problem. Now the other method you could use is you could use this second equation right here. Instead of solving for I1, you could solve for I2 and work it out and get the same answer. So if you guys really want to test your skills, I recommend, since I already gave you this solution to this method, if you want to practice your algebra, try working it out using this second equation here, and that will help you gain more confidence in your algebra. So when you come up with these, when you look at these circuits and you start coming up with these equations, you're going to notice that, hey, I might have more equations than I know what to do with. The thing is, you have to pick one. So what I always do is I recommend is basically we have to come up with three types of equations. One is how do all the currents relate to each other. Two, how does the power relate to each other. And three, how do the parallel circuits relate to each other. So once you come up with those three types of equations, you can write them all out. Then you can decide, okay, which ones do I want to use to solve for. And you know, what's difficult is you might solve for one and you're like, oh man, it's easier if I go this route or that route. So that's where the confusion gets on. So really, that's a lot of algebra, and to get that intuition, you just have to do more and more and more problems and work out the problems. It doesn't come easy unless you do it over and over and over again. So that's where the headache comes in with Kirchhoff's laws. It's not knowing which equations to use, and students get very, very stressed out when they're trying to solve these problems, and that's why this is the most difficult lab that you're going to face, because it's not just one solution that you guys could have. You could have different solutions based on what route you choose and how you choose to solve these problems. But the methods are the same. So if you follow these three steps, hey, how does the currents relate? How does the voltage relate? And how do your third relations relate? Then you guys should be doing okay. So now I'm going to show you an example of the third circuit, how to set it up. I'm going to skip the second one because the second one is similar to this one, except you have one more parallel. So instead of having two voltage equations like this, you're going to have three that you could potentially use. And instead of having one equation like this, you're going to have two. So you're going to have more, which is okay. The third circuit, it's the same, but it has another series portion to it. And I think that one's more challenging, so I'm going to set up those equations for y'all. And with those equations set up, I think you should be able to almost complete the lab. So let me move on to that. Okay guys, this is kind of crude drawing of what your third circuit looks like. But what you notice is you have another series parallel circuit. It's a little bit more complex. But essentially we're going to be doing the same thing. The first thing you want to identify is your current equation, how that's going to work. And you're going to notice that your current's going to split. Instead of one junction, now you have two junctions, right? So the current's going to travel up, it's going to go down, go straight, then it's going to get to another junction, it's going to be able to go down and straight. So you have a double parallel circuit. You also have another series portion. You have a series portion here, and you have a series portion here, so that's where you have to be careful at. So then you could make your power equations, which I showed you right here. You could say delta V is equal to IR1 plus IR3. So just remember from my last video, or the last part of the video. You could do the same thing with this, with IR4, or you could have this equation right here. I'm just going to go ahead and choose this equation. Of course, I didn't work this one all the way out through. I'm just giving you the guiding equations. I'm gonna choose this equation right here. The next thing you're gonna want to do is ask yourself, how does the currents relate to each other? Well, or the loops. So you could say IR3 right here, the current here is equal to the current of IR4. You know, that's just basically saying this going in here is going to equal to this coming out. Alright? You then are going to want to look at this portion, looking from here to there, and you can say IR4 is equal to I2 plus your resistor 5 and resistor 2. Now, you might be asking, where's I5 at? Well, I5 and I2 are equal to one another, so we just factored that out. Alright? So that's what we did here. I2 and I5 are the same in a series circuit, because remember, in a series circuit the current is the same. That is why last week when I said in simple circuits, it's very important that you understand the difference between a series circuit and a parallel circuit, because we're going to exploit those definitions in these calculations. So what I recommend doing is using this. Oh, this is supposed to be, I think, a 4 here. Or is it? Yeah. What I recommend doing in these is try to get everything in terms of I4, and then plugging it back in. So essentially, you're going to do the same system of equation approach, right? So like last time we said, okay, we have 3 equations, 3 unknowns. Well, now we have 4 unknowns. Look, we have I1, I2, I3, I4. So that means we need 4 equations. So here's 1 equation, right there, 2 equations, 3 equations, and 4. So here's your 4 equations that I recommend you guys use. Now the circuit before this, you do the same approach. The only thing that's going to be simpler is you're not going to have this series portion. So if you could do this one, you could do the one before this. So that's why I didn't really talk about that. But essentially the algebra is the same. You're going to have to get everything in terms of one common thing. I think with these equations, the easiest thing to get everything in terms in is I4. So you could divide this R4 over here and or whatnot, because this is I believe this is I4 right here. Or no, you could do it the opposite way. But as long as you get everything in terms of one thing, in this case, you could use I4. You could factor that I4 out. Once you factor that out, then you could solve for that. Once you know I4, then then you could use these equations to fill in the blank and then work your way backwards, like we did in the first example. So that's essentially the hardest circuit you guys are going to see here. Last circuit is fairly simple, so I won't cover that, but if anybody has any questions, please let me know. But you should have covered this in lecture, but if you haven't got to this portion of lecture, please feel free to email me any questions, or if you're having a really difficult time, we can set up some virtual office hours. But thank you guys, and have a wonderful day.